These measurements are made on an NMOS amplifier for which the drain resistance is RD. That is, drain resistor RD is 20 kilo ohm resistance. First, DC measurement show the voltage across the drain resistor. VRD to be 1.5 voltage and the gate source bias voltage to be 0.7 voltage. Then AC measurement with small signal shows the voltage gain to be minus 10 voltage per voltage. What is the value of VT for this transistor? If the process transconductance parameter Kn prime is 200 microampere per voltage square, what is the Mosfet's W/L? Okay, now let's go ahead and see one by one. So first we have to find out the V threshold, and let's look at the circuit. This is an NMOS circuit, so it's gonna be like this. We are gonna have the VDD on top. This is the drain voltage, and this is going to be the drain resistance, and the MOSFET is going to be arranged like this, and the current should be exiting right here, and this is our gate, and they provided the RD to be 20 k ohm resistance, and they have given the VRD. VRD is basically VDD minus VDA. This is drain to source voltage. So here this voltage right here is going to be VDS, and if you subtract this one by this one, that is the VRD, and that's given to be 1.5 voltage. Okay, that is the voltage across the resistor, and we have the VGS provided, that is gate to source. This is our gate and this is our source, and VGS is going to be right here, that is 0.7 voltage, and the gain is given by negative 10 voltage by voltage. Okay, let's note that down. AV is equal to negative 10 by 10 voltage per voltage. So these are all the information available, and the question is asking us to find out the V threshold first. So in order to find the V threshold, we can use the gain equation. Gain is given by AV is equal to minus 2 times VDD minus VDS divided by V over drive. Now here we don't have the VDD available, we don't have the VDS available, but we have the VRD, that is the whole thing. VDD minus VDS is equal to VRD. So instead of this, we can replace that one with VRD. So this equation becomes minus 2 VRD divided by V over drive. And V over drive is nothing but VGS minus V threshold. So we can express this one in that way as well, because we are trying to solve for the V threshold, so we need to have that one here, VGS minus VT. Okay, and we know the gain to be negative 10 voltage per voltage, so put that one here, rearrange this equation and solve for VT. So here, if I rearrange this one multiply in the other side, so 10 times VGS minus VT, and in the other side we are going to have minus 2 VRD, and therefore VGS minus VT is going to be 2 VRD minus 2 VRD divided by minus 10, and minus cancels, and 2 VRD divided by 10, that's VRD by 10, VRD by 5. So, and we need the VT is currently negative, so I have to move to the other side. So this is going to be VGS minus VRD by 5, that is equal to VT. Okay, let's go ahead and plug all the values and find what it is. So VT therefore is VGS minus VRD divided by 5, and VGS is provided in the question, that is 0.7, so plug that one right here, and then VRD is provided also, that is 1.5, plug that one here, divided by 5. 1.5 divided by 5 is 0.3, so this is going to be 0.7 minus 0.3, that is equal to 0.4 voltage. So the V threshold is 0.4 voltage. And there's another part of the question that's asking, if the process transconductance parameter Kn is 200 microampere per voltage square, what is the Mosfet W/L? So they have provided the Kn prime, that is equal to 200 microampere per voltage square, 200 microampere per voltage square. So how we can find it? So what you can do is here also we can use the gain equation. There's another gain equation, that is AV is equal to minus Kn V over drive times RD. Why this one is helpful? Because Kn is basically Kn prime times W over L. So if you know the Kn, then we can solve for the W over L. So okay, so Kn, finding Kn is helpful for us. AV is already there, that is minus 10, and then Kn is what we are trying to find, and then V over drive is VGS minus VT. Okay, we have the VGS available, that is 0.7, and V threshold we just found out to be 0.4 right here, so we can plug that one right here. VOV is VGS minus VT, so that is basically 0.7 minus 0.4, and then RD is available to us, that is 20k ohm resistance, so put that one right here as 20k. Then if we solve for Kn, that one comes out to be negative cancels, therefore this one is going to be just 10 over 0.7 minus 0.4, that's 0.3 times 20k, and that will give us 1.67 milliampere per voltage square. So now we have the Kn, and also we know that Kn is equal to Kn prime W over L, and we have the Kn prime also available, that is 200 microampere per voltage square. So we just have to rearrange this equation and solve for W over L. W over L becomes Kn divided by Kn prime. So Kn is 1.67 milliampere per voltage square, and then Kn prime is 200 microampere per voltage square. Solve for this one, you will end up getting 8.35. That's the width over length ratio. And that is it for this video. I hope you guys found this video helpful. Thanks for watching. Don't forget to subscribe my channel. See you guys on my next video.